everyone. In this video, we will be simplifying expressions using properties of exponents. This is the first part. I will put the link of the second part in the description box below. Let's take this first example right here. 3x squared plus 2x to the fifth power. So this example would require us the product property of exponents. So what are we going to do here is that if we have if their bases are the same, we are supposed to add their exponents. So in this case right here, we are going to multiply the coefficients 3 and 2. That would come out 6. So I'm going to write 6 here. And then for their exponents, since their bases are the same, we are supposed to add them. So we can go ahead and write x, that would be 2 plus 5, and that would be 7. So then we can go ahead and simplify this as 6x to the 7th. So this is the product for these two expressions here. Now I will show you another method, which is the expanded version of this. So what are we going to do here is that we are going to expand this. We're going to write all the x's here, how many x's are involved, because sometimes others forget the rules or the different properties of exponents. So the other way to do it is to expand it. So we have a 3 here, so I'm going to go ahead and write 3. And then it says that it's x squared. It means that there are 2 x's. And I am going to multiply that by 2x to the fifth. So there's 2 in front, which is the coefficient, and there's going to be 5 x's. So that would be 1, 2, 3, 4, and 5. So what I'm going to do now is I will multiply their coefficients. So that would be 3 times 2 would be 6. And then I'm going to count all the x's. That would be 1, 2, 3, 4, 5, 6, 7. So that is 7 x's. As you can see here, both methods are just getting the same answer. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, and pause it and check your answer. Okay, so we go over the problem here. So this is pretty much using the product property, but instead of the dot, we're using the parentheses, but it's pretty much the same thing. So there is an invisible denominator of, there is an invisible coefficient of 1 here, so that we can go ahead and multiply the 1 and the 5. So that would be 5. 1 times 5 is 5. And then we have a y to the fourth and y to the second power. We can actually add them together because that's the power property of exponents. So that would be y would be 4 plus 2. So then we go ahead and equal this to 5y to the sixth power. So this is the product of those two expressions right there. Or we can expand it. That means we are going to write 4y's. So that's 1, 2, 3, 4. So that's inside the first parentheses. The other parentheses would have 5 and then 2y's on it. And then we multiply the 1 and the 5. So that would give 5. And then we count all the y's. So that would be 1, 2, 3, 4, 5, 6. So there are 6 y's. And as you can see here, both methods are just getting the same answer. Okay, so let's move on to the next example right here. So this time around, in this problem right here, we are supposed to use the power of a power property. So in a power of a power property, it means that this power here is also a power to each of them. So it does not only go with y, it goes to each of them. So we can go ahead and simplify this as 5. So the 5 is inside the parentheses. So I'm just going to go ahead and write 5. And again, that's inside the parentheses. I will square it. So again, each of these, so pretty much like each of these is going to get the exponent too. So not only the y or not only the 5, it should be each one of them. So x cubed or x to the third power is inside the parentheses and it's raised to the power 2. And then y, which has an invisible exponent of 1. So that's y to the 1 is also raised to the power 2. So then from here, we can go ahead and simplify this to be, so that would be 5 squared would be 25. And then x cubed and then squared. Using the power of a power property, we're going to multiply this. So that would be x to the 6th power, and multiply 1 and 2 would be y squared. So this is the answer to this, or the simplified version for this expression right there. We can also simplify it some more to better understand this. This means that this part right here is actually, we can expand it as 5 times 5. So I'm just going to write 5 times 5. That means there are, we multiply 5 twice. And then this next one right here can be simplified as there would be 3 x's inside the parentheses. 1, 2, and 3. And it says that there are 2 groups of these 3 x's. So I'm going to write another 3 x's here. So this is what it means by x cubed to the 2nd power. So that means inside the parentheses, there are 3 x's. And the square here tells us that there are 2 groups of 3 x's. And then this one right here would be, there's like, inside the parentheses is y. And then it says it's raised to the power 2, so that means there are 2 groups of them. So we can still get the same answer. So from here, we can go ahead and say 5 times 5 would be 25. And then we count the x's, 1, 2, 3, 4, 5, 6. So x to the 6th. And then there are 2 y's, so we get y to the 2nd power. So we still get the same answer as this. So both of these are a match. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, pause it and check your answer. Okay, so we go over this. So this problem right here is a combination of the product property and a power of a power property. So a product of these two and the power of a power property. So we are going to simplify this part right here first. So remember that for a power of a power property, that this is the power to each of them. So we can go ahead and simplify this as this would come out 2. So the 2 is inside the parentheses. I'm going to write 2, and then that's raised to the power 3. The x is inside the parentheses, and that's raised to the power 3. The y squared is inside the parentheses, and that's raised to the power 3. And then we got a 3x squared y. So then from here, we can simplify this. 2 to the power 3 means 2 times 2 times 2. And then that would be 2 to the power 3 would be 8. And then x, there's an invisible 1 right here. Remember, for power of a power property, we're multiplying this. 1 times 3 is 3. So that would be x to the 3rd power. And then y, 2 times 3 is 6. So that would be y to the 6th. And then that is multiplied by 3x squared and then y. So then from here, we can multiply the coefficient. So 8 times 3 is 24. So that would be 24. And then using the product property, we're going to add the exponents of the x's. So that would be x and then 3 plus 2. So we're adding their exponents. And then, so that's for the x. And then the y here, we're going to add them as well. So that would be y to the power 6 plus 1. Because again, there is an invisible exponent of 1 right there. So then from here, we are going to simplify this. So that would be 24 x to the 5th, and then y to the 7th. So this is the simplified version of this expression right there. Did you get the same answer as this? Good. Perfect. Now let's move on to the next example right here. This time around, we are going to use the quotient property for this. So for the quotient property, we are supposed to first, we are supposed to divide this 15 and 3. So I'll show you the direct way to do it. So using the quotient property, so 15 divided by 3 is 5. And then for the quotient property, we are supposed to subtract the exponent. So if their bases are the same, so I can go ahead and write y. 7 minus 4 would be 3. So then again, I am subtracting this because I am dividing. So this would come out 5y to the 3rd power, because we have 7 minus 4 is 3. Now I'm going to show you the expanded version for this. because again, sometimes others forget the rules and they remember better the expanded version. So what are we going to do is we have 15y to the 7th. So to expand this, that would be 15, and I'm going to write 7y's. 1, 2, 3, 4, 5, 6, 7. And then we got 3 and then 4 y's at the bottom. 1, 2, 3, 4. So I expanded it. Now the next thing that I would do is I will cross out those, like a giant one. If you divide it, they're gonna get crossed out. So this would be, partner them up and cross them out. So the leftover would be 15 divided by 3 is 5. And then we are left with 3y. So that will be y, y, and y. So pretty much 5y to the 3rd power. So as you can see, both methods are getting the same answer. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. So the direct way to do this is using the quotient property. We can go ahead and divide these two together. Negative 28 divided by 7 is negative 4. And then I'm going to write x. Remember, since this is division, they have the same base. I'm going to subtract it. So 5 minus 9. So then I can go ahead and equal this to negative 4. And then parentheses, that's just going to be x to the power negative 4. Now, it says here that we want to have a positive exponent. Now, we are going to use the property of negatives for this. So, the property of negatives means that if we are going to flip the fraction, then we are going to change the negative exponent to positive or the positive exponent to a negative. So, remember that this one is an invisible denominator of 1. So, then we can go ahead and rewrite this as that would come out negative 4. And then that is, I'm going to flip this fraction right here. So that would equal to 1 over x to the 4th. That would be a positive now since I switched it. Again, this is based on the property of negatives. So then from here, we multiply these two across. Remember, this one has an invisible denominator of 1. So we can go ahead and say negative 4 times 1 is negative 4 over x to the 4th, and this is the simplified version for this problem right here. Now, I'm going to show you the expanded version for this to see if they would come out the same. They should come out the same. So first, that's negative 28x to the 5th power. So that would be negative 28. And then I'm going to write 5 x's, 1, 2, 3, 4, and 5. And then that is over. That's going to be 7. And then I'm going to write 9 x's at the bottom. 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then what are we going to do is we cross them out. So I'm going to partner them up and cross them out. So these two gets crossed out. So the leftover would be negative 28 divided by 7 is negative 4. And then we crossed out everything. There's no x on top, so we're good. So that would be over. We count the x's. So 7 is gone already because I divided it with negative 28, and that's equal to negative 4. Now I'm going to count the x's, 1, 2, 3, 4. So I'm going to write 4 x's here. And pretty much this one is actually negative 4 over x to the positive 4, since there are 4 x's at the bottom. As you can see, both methods are giving us the same value. Now let's move on to the next example here. So in this example, we are going to use both the product property and the property of negatives as well, since we have a negative exponent here. And then again, our task is to come up with an expression, a simplified version of this with all positive exponents. So we need to get rid of the negative 4 right there. So what are we gonna do here is that we can rewrite this. So this would be 5x, that's gonna be to the power 3 times 2. And then remember the property of negatives. This is this one has a denominator, invisible denominator of 1. So if I flip this fraction, this will change the 4 into positive. So I can go ahead and rewrite this as 1 over x to the positive 4. Okay, again, once we flip it, then the exponent will turn into positive. Or if this was positive, if we flip it, it turns into negative. Again, that's the property of negatives. So then from here, we can simplify this as 5 x to the third times 2 times 1 is just 2 over. Remember, there is an invisible denominator of 1 to the 2, so that would be x to the fourth. And this one has an invisible denominator of 1, so we can go ahead and multiply them across. So this would come out 5 times 2 is 10 to the 10x to the third power. So because 5 times 2 is 10, and then we have an x to the third power. And that is over 1 times x to the fourth is just x to the fourth. So then we can go ahead and simplify this some more. So in order that we can simplify this, we can expand it. So that would be 10. So on top, we have 10, and there are 3 x's. And then at the bottom, there are 4 x's. So then we can cross cancel these two. So I'm going to cross this out, partner them up, and cross them out. So the final answer for this would be, so the top, we're left over with 10. And then the denominator is just 1x, or you can just go ahead and write x. And this is our final answer right here. That's a simplified version for that expression right here. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. So in this problem right here, we are combining the product property, the power of a power property, and the property of negatives. So those 3 properties are combined together in here. So what are we going to do first is remember that this, the power of a power property, this is the power to all of these numbers inside the parentheses. So that means we can go ahead and rewrite this as negative 2 is inside the parentheses, and that is raised to the power 3. The x is inside the parentheses, and that's raised to the power 3. The y to the negative 2 is inside the parentheses, and that is raised to the power 3. And then we, this is pretty straightforward, so that's 3, and then that's x to the negative 2, and then y to the second power. Now, we need to have a positive exponent, so we're going to simplify these two first. So this would come out negative 2 cubed. It means that we are going to multiply negative 2 3 times. So negative 2 times negative 2 is a positive 4. Positive 4 times negative 2 is a negative 8. And then that is x to the third power, because there's an invisible 1. Remember the power of a power property? 1 times 3 is 3. And then this one can be simplified as, remember this one is an invisible denominator of 1. Once we flip the fraction, we can actually change the sign of their exponent. So this would come out 1. I flip the fraction. That's 1 over y squared. So the exponent now is positive, and that's what we wanted. So then this is raised to the power 3. And then that is times 3. And then this one, we can change this. Again, this one is an invisible denominator of 1. So then I can go ahead and write this as 1 over x squared, so that it has already a positive exponent. Again, that's what we wanted right there. So then we can go ahead and write y squared. So then from here, we can simplify this some more. So that would be negative 8x cubed. 1 cubed is just 1 cubed is just 1, and then y to the second power raised to the third power would be 1 over y to the sixth power, and then that is equal to 3, and then we keep that the same. That's 1 over x squared y to the second power. Now we are going to multiply the constants. So the negative 8 and then the negative 3 will be multiplied together. That would come out negative 24. So I'm just going to write that over here. So that is negative 24. And then the x's here, on top, all the tops here would be x to the third. So I can write x to the third here. Because there's a 1, so I don't need to write that. So negative 8 times 3 is negative 24. We get an x cubed and we get a y squared. So I'm going to write y squared right there. And that is over. So all the denominators, we're going to multiply them. That's 1, y to the 6. So I'm just going to write y to the 6th. And then there's another x squared. So this will be, that's going to be x squared. Let's have the expanded version for this. So I'm going to show that down here. So we are now having the expanded version. So that would be negative 24. And then there are 3 x's, 1, 2, and 3. And then 2 y's. And then that is over. Then we have here 6 y's. So that would be, I can put together all the y's here. So that's going to be 1, 2, 3, 4, 5, and 6. And then there are 2 x's. So I will put them like on top of each other. So it's faster to cross them out. So then from here, we can go ahead and cross out the 2 x's here and the 2 y's. So then from here, we can go ahead and say that the final answer for this would be negative. So I'm just going to write that down here. So negative 24, there's 1x on top, over, that would be 1, 2, 3, 4, y to the 4th power. So this is the simplified version for this expression right there. Did you get the same answer as this? Good, perfect. If you find this video helpful, hit like and subscribe for more math videos. See ya!